All right, ladies and gentlemen, we're a little bit early, and I'm just giving you guys the opportunity to start sending in questions. And I'm going to get myself together on my end. Okay, YouTube. Okay, okay, I have that up. And going live on Facebook. Okay, I'm not sure if Christopher McLeod is here. Okay, if you're trying to get in contact with me on Skype, it is KIENO.Thomas. You can send me a contact request. Um, Come on back. Like I said, we're a couple minutes early. We're starting at 5 o'clock. Start sending in those questions. And I'm Kino from STEMWithKino.com, and I'll welcome you all. Even if you guys out of the three tests, SIFT, ASTB, um, and the AFOQT, which one is the hardest? I'll address that in a minute. Okay, all right. And that's a lowercase k, just so you guys know. Wow, that camera looks pretty clear. Facebook. Get all my pages up here. All right, I got my Facebook. I got my YouTube up. Harry B, I'm going to address your question in a moment here. And I had this hanging up for whatever reason, but take that down. Okay. All right. First off, Harry B, where are you from, and which test are you preparing for? Number two, let's see. SIFT, ASTB, AFOQT. I think that the aviation selection test battery is the hardest. The SIFT, actually, believe it or not, comes in second place, only because of the mechanical comprehension and the physics questions that have been added to it since the inception of that test. The SIFT used to be called the AFAST test, but now it is the SIFT, which is a standard instrument for flight training. So even if you are preparing for a SIFT, you can bring math and mechanical questions here because they apply to the United States Navy's aviation selection test battery and officer aptitude rating. So, whether you come to this live or say tomorrow SIFT and Navy, you can still bring or introduce math and mechanical comprehension questions because it's beneficial. It's beneficial on both sides. So, let me just see how we're looking. Stacy, good to see you. Harry B. And on the YouTube side, now you have to be following me on Facebook, on the Facebook Live, if you want to see the questions. They are on the post page. It is STEMWithKino.com. And DRG, what's going on, DRG? So yeah, if you actually want to see the questions, you know, because they have multiple choice answers, and then there's some reasoning past the ASTB. Okay, so I'm gonna read that in a moment. Harry B. All right. Okay, okay. I will drop the link for the post page if you want to actually follow the questions that are going on. Copy on YouTube. So yeah, but first I was like, oh, you know, it's just gonna be Facebook, but you know, I guess I get maximum visibility. Right, Mike in the house. Okay, Harry B, you've taken the ASTB and AFOQT. You passed the ASTB. I need to retake the AFOQT. I was thinking AFOQT. If I have identical sections, I know section mechanical. Yeah, they're all going to have reading. You're going to have reading comprehension in all of them. No getting around that. But the mechanical part of it has introduced physics, and then that's where a lot of people kind of tend to have a barrier. To have a barrier going on. So, okay. As usual, Darren's coming in with the questions. Shout out to you, Darren. All right. And let's see here. Boom, boom, boom. So I'm going to the post page, and I am dropping this on the post. And the link is there on for my YouTubers if you want to actually see the question. All right, so the question is as follows. Let me get it to post. Okay. There's a bar which is exactly 4 inches in length. It has a weight on one side that's 275 and a weight on the end, which is 125 pounds. On the opposite end, for the bar to balance, the distance from the 275-pound weight. For the bar to balance, the distance from the 275 weight to the fulcrum point should be, I think that should be, that there's a typo there. All right. So but actually what they're doing is they're asking us where to place the fulcrum. So let's dig in. Darren put me to work quick today, didn't he? All right. So we have a bar. It's 4 inches long. And on this side, we have a 275-pound weight. And on this end, we have a 125-pound weight. LBS. So they're asking us where along this point do we put the fulcrum in order for it to balance. Now, we have 1 1/4 inches, we have 1 inch, and then we have 3/4 inches. Now, the whole idea of this is to make sure that the load moments are equal. Wherever we put the fulcrum, we want this thing to balance like a seesaw. So we know that the arm, I know that the arm is going to be closer to the 275-pound weight because you need more distance to produce a higher load moment. So you have an inch, and that's what I would go for the inch and check the load moments. Now, if we place the fulcrum 1 inch, here you're gonna have 1 inch there, and you're gonna have 3 on this side. All right, so this is gonna produce a load moment of 275. It's weight times distance. So this is gonna produce 275 inch pounds. And on this side, it will be 3 times 125. 3 times 100 is 300 times, so 375. So we're going to have 375 inch pounds on this side. And in order for this thing to balance, it's going to have to be equal. So now that I know if I set it at 1 inch, now my only 2 options are I could put a shit this way, or I can push it this way. It's going to have to move towards the 275. So this one is lower. So it's going to have to shift this way so we get more arm to multiply. So I'm going to go with 1 1/4 inches. And if everybody understood what I did, please type 1 in the chat. Please. And George, welcome to the room. Thank you for liking the page. And Stacy, were you trying to reach out to me? I think via email or something like that. I think. But yeah, I don't know if you were here on the early part. But yeah, just hit me up on Skype or my Gmail. You know, but because Messenger, I don't know, it's weird. Like sometimes I like, okay, you get something in your inbox, and I'm like, but it's so little, and I don't know. And shout out to Christopher McLeod. Thanks for your interest. Yeah, hit me up on Skype, Kino.Thomas. I had that up earlier. Where did you get the 1/4 inch? Well, the answer options, I think one was 1 1/4. Let me look at it again. Your answer options, 1 1/4 inches, 1 inch, or so we can set this at the 1 inch mark, the 3/4 inch mark, or the 1 1/4 mark. So it needs to be 275 at the 1 1/4, because if we put it at the 3/4, it's going to have a bigger load moment than where it already is. We got 375 inch-pounds. So we need more load moment, distance, and weight on this side. So we push it there so that the arm distance from the weight to the fulcrum is bigger. All right, welcome, everybody. And thanks for that, the assistance there, Mike. All right, and we see our ones. Okay, you did type 2. I'm just flying all over the place. Okay. Send those questions. If you're already attached to me on Skype, you can drop questions via Skype, and then I can cross them over to the Facebook post page for everybody to see. Okay, I'm gonna check my Gmail because I know sometimes you guys send questions via Gmail. I'm checking that now, and yes, we do have questions there. Okay, y'all really hit me with the weight and balance questions today, aren't you? Okay. Okay, so let's get the most closely related one out of the way first. All right, so the fulcrum in the middle. All right, I'm dropping this on the post page. And give me a moment, copy and paste. And it is dropped. And again, guys, if you got to be following me on Facebook if you want to see the questions. Facebook doesn't have like a utility for me to, unless I was in Google Hangouts, but let me refresh the page. And okay. So a lever arm is in balance when the force X length of one side of the fulcrum is equal to force X length of the other side of the fulcrum. With this information, test this concept. The force needed to balance the lever is in pounds most nearly what? So what they have on the diagram from my YouTube people, is we have a fulcrum that's in the middle. And we have a 5 and a 10-pound weight. Attached here. And the fulcrum should actually be like that. All right. So then we have an arm here, and then we have an F here for force. So basically, how much weight are we going to put here is the question. This is a first-class lever system. And I think of the fulcrum as an equal sign because the load moments on this side need to equal the load moment on this side. Now there is some additional, okay, there we go. All right, so 3 inches. So the distance to this is 3 inches, and there's another 3 inches. Now you have to be careful because a lot of people get this misconstrued, and a lot of students do this when I'm thinking, because they will say, okay, well, this is only 3 inches away. It's not, it's 6 inches. This is 3, and that's another 3, so this is actually 6 inches away. This distance is 6 inches from this side to this side, so that's 6 inches all the way, and that is 6 inches as well. But the midpoint is 3 inches. So the load moment is a product of weight times distance. All right, so we have to figure this out. Okay. 10 is 3 inches away. So this is 30 inch-pounds. 30 inch-pounds away. And this is 6 times, because 6 times 5 is 30. So this is also producing 30 inch-pounds. So we have a total of 60 inch-pounds on this side of the fulcrum. So we need to produce 60 inch-pounds on this side. And so are we going to use a 10-pound weight, a 14-pound weight, a 15-pound weight, or 18-pound weight? It'll be the 10-pound weight. Because when we put the 10-pound weight here, the load moment will be 6 times 10, which is 60 inch-pounds. So we have 60 pounds on this side and 60 inch-pounds on that side. And it'll balance out. All right. And guys on YouTube, please hit the like button if you haven't already, please. And if you understood that question in YouTube land, type 1. Facebook as well. What equation? There's really no equation I'm using, Stacy. It is just understanding load moment. Load moment is distance times weight. 60 inches, 60 pound inches. 6 inches times 10 is 60 inch-pounds. On this side, 10 times 3 is 30 inch-pounds, and then 5 times 6 inches away is an additional 30 inch-pounds. All right. All right. Okay, Jonathan, Tom, and right. Okay. Good. Okay, Leonardo, good to see you in the room. And, it's not, it's not, when you say, okay, well, that was so easy or whatever, I just explained it. Everybody perceives things in different ways. As a teacher, if I'm in a classroom, I can be teaching anything. There's going to be each individual student perceiving what I'm saying different ways. So what might look easy to someone may not look as easy to the other one. And so let's keep that in mind. You know. All right, 2 inches either. Okay. Okay, dropping another pulley. It's not like the traditional pulley question. It's more of a belt. Well, yeah, I guess it is. Yeah, they are pulleys. All right. Dropping the question now, ladies and gentlemen. All right, hold on. Let's see what we got here. Okay. All right, dropping it on the Facebook post page. And for my YouTubers, I think what I'm gonna have to start using OBS or something like that, so you guys can actually see these. I'd like everybody to see the actual questions and answers and things of that nature. But we have an arrangement. There's a pulley arrangement, and I'm gonna draw this as nicely as I can. But here we go. You have a diagram, and you have one small, 2 medium, and 2 large size pulleys. All right, so we have pulley number 2, which is small and in the middle, and then you have the medium sized pulleys here and here. And then you have 2 larger pulleys here and here. That came out pretty good. Okay, so let me label 1, 2, 3. 1, 2, 3, 4, and pulley 5. So there's 5 pulleys, and basically the belt is running like across here, up here, down, and this is like an adjustment or tension pulley here, where it's probably a bolt on the bottom that you can make it move to apply tension or release tension. In the diagram, which one of the FF statements is not true? Okay, A, pulley 2 would spin faster than pulley 4. Oh, and I didn't even make note of that. They're showing the direction of turn. So the belt's running like this. Now, just right off the bat, pulley 2 is the smallest, and it's going to turn faster. It's going to turn faster than all of them. The second fastest pulleys are 1 and 3, and the slowest pulleys are 4 and 5. So, all right, in this diagram, which statement is not true? Not true. Not true. All right. Is it not true that pulley 2 would spin faster than pulley 4? That's true. It's not true. It's so crazy the way this is worded. All right. So it's true that pulley 2 spinning faster than pulley 4 is a true statement. So it's not untrue. So you throw A away. Pulley 4 would spin faster than pulley 3. No, that's not true, because 3 is smaller and it's going to spin faster than 4. So B may be possibly our answer. Pulley 1 would spin faster than pulley 3. That's not true, because they're the same size. They're going to have the same revolutions per minute. And then finally, pulley 4 would spin. That's not true either, because they're the same size. So it's answer B. Answer B. And if everybody got that, please type 1 in the chat, whether you're in YouTube or Facebook land. Okay. Jonathan, I will address that next in a moment. Okay. Very good. Okay, so I think one of the most important, most of these questions, they will give you a general question. And what they will do is they'll give you two circuits. One will be a series with two resistors in series, and then the other one will be in parallel. They won't really go into detail too much, but you have to understand Ohm's law. Ohm's law states that voltage is equal to current times resistance, but what I like to introduce is a Ohm's law triangle. V, I, R. So this is how it works. If I'm looking for voltage, I'll cover the V. I is current, R is resistance. All right. So if I'm looking for voltage, I cover the V. All right. If I'm looking for current, which is I cover the I. In mathematics, V over R would imply division. All right. So it'd be V divided by R. And then if I'm looking for resistance, I'll cover the R, and it is V, which is voltage divided by current. All right. So basically, we have to understand resistance. Okay, so they'll give you two resistors. They'll say, okay, well, in which system is the resistance the greatest? That would be this guy. And another question they may ask you, well, which circuit arrangement? If the resistors are of equal strength, which one is the weakest? It would be the parallel. And the reason why is because even if, let's say these were 5 ohm resistors, 5 ohms, 5 ohms here, and we have 5 ohms here. That's the omega symbol. And we have 5 ohms here. Because sometimes you're gonna have to just like, sometimes you're just gonna have to like place numbers in there. It makes sense to me if they just said, okay, these are of equal strength. If I really want to see the numbers, 5 ohm, or use, I don't know, 1 ohm resistors. I don't know. All right, but in a series circuit, your equivalent resistance or total resistance, R total, is R1 plus R2 plus dot, 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 which means however many resistors you have in that circuit is going to be your total resistance. So we have 10 ohms of resistance, total resistance here. Well, in the parallel world, it is, and let me just make sure I'm giving you guys the right information, because people will be like, Kino, you got that wrong, and oh my God, it's the end of the world. All right, resistance in a parallel circuit. I want to make sure I'm writing this down.
According to swtc.edu,
Okay.
you can find total.
Didn't want all that, but here we are, so let me back up. All right, so in the parallel world, your resistance total is going to be equal to 1 over 5 plus 1 over 5. So we can see that this is not going to be, and my people, I want you to calculate 1/5 plus 1/5 for me, because we have 10 ohms. And let's see here. Let's get that total resistance. Anybody in YouTube land can answer 2/5. 2/5. So what is 2/5? It is what? 40%? 20, yeah, 40%. Or 0.4. So we would have 0.4 ohms. We had the same two resistors, but in series, we have 10 ohms of resistance. In parallel, same 5 ohm resistors, we have 0.4 or 2/5 of an ohm. So it's not even, we took 2 5 ohm resistors, and we don't even have 1 ohm of resistance. I think I said that right. Okay. All right, so hit me with a 1 on Facebook and in, 0.4 ohms. Good job. Good job, everybody's responses. 0.4 ohms or 2/5. All right. All right. Okay, a couple enabling objective terms for all my aviation wannabes for the my aviation officer candidates. Give me a second. I'll pull it up. Worksheets and that's pro. Or do I have that in ground school? Okay, here we go. Matter of fact, you know what? No, we're going to talk about weather. A weather enabling objective. For all of you guys that are doing the aviation pre-flight indoctrination. All right. We have enabling objectives that you're going to run into an API, and these comes from a trainee guide. All right, so enabling to describe the characteristics of the troposphere. Okay, the troposphere is the lowest level of the atmosphere. It's where all the weather happens. All the weather happens in the troposphere. And another common question that has come up: the characteristics of the entire our atmosphere. Everybody thinks no, it's mostly oxygen. It is not. It's about 78% nitrogen. And 21% is oxygen, O2. And then we have 1% what we call trace gases. All right, the trace gases consist of carbon dioxide, argon, helium, and neon. All right, so the troposphere is the lowest level. That's the composition of our Earth's atmosphere. The troposphere is the lower level, the lowest level of the atmosphere. And some characteristics that we get in this atmosphere is, it's called the troposphere or trope. I think the Greek or Latin root means to change. And there's a significant temperature change. Well, not significant. It's every 1,000 feet. We're going to lose at least 2 degrees Celsius or 3.5 degrees Fahrenheit for every 1,000 feet. Now, there are standard numbers that we use in our atmosphere. We use 29.92 inches of mercury, Hg. All right. What that means is like the weight of the atmosphere at sea level. If I had a barometer, kind of like that, right? And I open one end and I put mercury in here and I uncapped it, the atmosphere is going to exert itself. The weight of the atmosphere is going to push it up to 29.92 inches. So that's what we mean by 29.92 inches of mercury. 15 degrees Celsius, 59 degrees Fahrenheit. All right. So that is the standard atmosphere. The atmosphere is never standard. I've yet to, I don't think I ever remembered a time where I listened to ATIS or something like that when I'm about to take, ATIS is the Automatic Terminal Information Service. And you listen to them and you listen to this frequency, it tells you all the airport conditions. So I don't think I've ever switched to ATIS and its altimeter setting to 992. I don't remember, I don't recall. It's always something weird. But never 2992, so there's no such thing. I believe it might happen from time to time. I've just never witnessed it myself. But these are standard temperatures that our instruments are kind of calibrated by. Okay, in this perfect atmosphere, 2992, 14.7 pounds per square inch, 1013.2 millibars. All right, so back to lapse rate. Every 1,000 feet of altitude, we're going to lose 2 degrees Celsius or 3.5 degrees Fahrenheit. So it is characteristic in the troposphere for our temperature to drop as we increase altitude. All right. So yeah, I'm going to start like putting these, need to know aviation type terms out here because it's really, really important. Okay, Darren, where you at, man? He's looking up something. And he did. He found something. This is more of a mechanical comprehension test that we are question. We are dropping, or I am dropping, on the timeline. Hey, Mish. All right. I am posting this on the post stemwithkino.com post. Okay, basically what we have here is a oil tank. And in this oil tank, I'm just waiting for the picture to post. And YouTube guys, I'm going to put it on the board. No worries, don't worry. So we have an oil tank, and it is at the 6-inch mark. All right. If an 8-inch level indicates 16 quarts of oil, then the number of quarts of oil to be added to raise the level from 6 to 8 is 2 quarts, 4 quarts, or 6 quarts, which is our answer. All right, so for my YouTube people, we have an oil tank. And we have our oil in here. All right. And it's currently at the 6-inch mark. And I guess the top of the capacity is 8 inches. All right, so if an 8-inch level indicates 16 quarts of oil, then the number of quarts of oil to be added to raise the level from 6 to 8 is what? Our options are 2 quarts, 4 quarts, or 6 quarts. All right, so here we are. We know that 18 indicates 16 quarts of oil, QTS. So that's a standard that they've given you. And I love proportions because it's great. So we'll put inches over quarts. All right, inches over quarts. So 8 inches represents 1/6 quarts. So we got to look at 6 inches. 6 inches represents how many quarts? So that's our X value. Okay, folks, somebody in the room help me out. 16 times 6 and then divide by 8. That's how you find the answer. 16 by 6, not the answer. This tells you how many quarts we have at 6. And then we deduct that from 16. So come on, my mathematicians out there. Where y'all at? I didn't think I was going to do all the work. Like, man, you're just supposed to be solving these. No, I need some crowd for participation. Big word, as my man Willie Williams would say. Big word, participation. I got 12. Who agrees? Mike comes in with 12. DRG comes in with 12. Okay, so if 8 inches is 16 quarts, 6 inches is 12. And cross multiplication, this times this equals this times this. 8 times 12 is 96, so 16 times 6 should also be 96, and I see that. 6, 3, 96. Okay, so the number of quarts needed to raise from 6 to 8 is 4. And if everybody understands that, please hit 1. Okay. Another question came in. Boom. 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 All right, guys, give me that ones. Give me those ones or twos if you did not understand it. And, maybe I need to make, go harder as far as explaining things better, which is okay. Because, like I said, everybody doesn't perceive everything the same way. All right. That's what we got here. And guys, to get the most out of this, every week, I'm here every week. Bring your test prep books. When you're studying throughout the week and you're looking to say, I can't figure this question out, bring it to the room. I will do it. Doesn't cost you a thing. Bring your books and let me, explain it to you because, most people, and I'll say that again, I talked to somebody, they took the aviation selection test battery 2 times. And I say this, I talk to them blue in the face. I'm like, dude, find a qualified instructor for this test. Find a qualified instructor. Find a qualified instructor. Most people are not prepared. Out of 10 years of training people for a lot of these exams, I've only met 3. I've met a lot of people via, Skype or, Google Hangout or whatever. I meet a lot of people, but only 3. I took them through like an hour session. It was like, dude, you good. Go take it. But most of these people had engineering backgrounds, where you deal with a lot of math. You deal with the physics. Hell, my degree, I had to take physics 1 and 2, and don't think that, all right, George, I got you, brother. You do the same problem with bigger numbers. Okay. We'll get to that in a second, George. But yeah, I only met 3 people. So don't go taking this test 2 times. You can only have one more time left. Find a qualified instructor that can train you properly and somebody with a good track record. That's important because you have guys preparing people for the aviation selection test battery that aren't even pilots. I'm like, how the hell that happened? Oh, you're going to tell me about stalls and, and I guess you could do it if you read up enough on these subjects, but I would probably want a pilot and an instructor with an instructor rating. Very, very important because, all right, so, just be smart. Don't go taking it. I would be like pulling my hair out, the hair I don't have. If I had to take this thing 3 times, like, and recruiters looking at you like, this guy. It just, it's just not a good look to be taking this thing multiple times. I mean, but, STEMwithKino.com is here for you guys. And yeah, Stacy, we did talk. And I'm just looking at your question now. It's sideways. So turn that thing 90 degrees next time on the circle. Center A. If the diameter of the circle is 75, what is the sum of AW? I've seen this question before. You probably would not get a question like that on a test. Mostly circumference, diameter, even cylinders. And did they give you an image? Because the test is going to give you an image to look at. I've always had issues with that question as Stacy. And Stacy, hit 1 if you got my message that I sent to you as well, because you asked me a question on a DM. All right. So, all right. So George, bigger numbers. Okay. George wants bigger numbers. Okay, you can do this with anything and using the proportion, and which we did do earlier today, didn't we, George? All right, so same question, and I think I need to. How do I step back on it? Okay, there we go. All right, so Darren, give me numbers. Just give me two random numbers, Darren. But big numbers. Or anybody, does it? George wants bigger numbers. We got to get George bigger numbers. Come on. I know there's a lag. 72. I like that. 72. 72. Need another number. Come on, Michael. Take us home, buddy. Okay, we'll run with 72 and half of 72, which is 36 inches. All right, so we have some really big tank. All right, and I don't know, let's say it's the space shuttle's oil tank, I don't know. So we'll make it wider and boom. So let's say that 50 inches. No, we'll say 50 inches is the size of the tank. So 50 inches equals 72 quarts. How's that for bigger numbers, George? So 50, all right, so 50 inches indicate 72 quarts. So how many quarts would need to be, would we need to fill up the tank? If our current, 36, 36 inches. Yeah, we got it. So right now, we have 36 inches. That's where our oil level is at. And we need to get to 50 inches or 72 quarts. Matter of fact, a better question. How many quarts is in this tank right now? 50 inches, which is the capacity, 72 quarts. But we dipped the tank, and we have 36 inches. How many quarts do we have? All right, John 181. Okay. All right, we'll get to that in a minute, John. All right. Okay, so I want you guys, if anybody can calculate that for me. The capacity of this tank is 72 quarts and 50 inches. We dipped it, we got 36 inches. How many quarts are in this tank? That's an awesome question. See? The brainstorming there, man. Thanks, George. That is a big number, George. That's a big number, bro. And you got to think about this, okay? But no, don't ever. A wrong answer is okay. It's okay. If 50 inches represents 72 quarts, 36 inches has to be less than 72 quarts because that's the capacity. So 2,592 will not do. All right. So again, it's a proportion. We have a standard. We say inches over quarts. All right. So 50 inches, 72 quarts equals, we have 36 inches, and x is the unknown. So 72 times 36 divided by 50 will yield our answer. Yeah, I should have an answer by now, guys. $36 times 72. Okay. You didn't divide by 50 though, Mike. I see what you did. I see why you got 2,592. But then you have to cross multiply, then divide by 50, which will yield 51.84 quarts. All right. So if we have 36 inches, we have 51.84, or we just round up to 52 quarts. Keep it simple. All right. Now, did everybody understand that process? Type 1 in the chat if you understood the process. Okay. Couple things I want to address. The earlier, I was asked a question about Harry B asked me a question about which test is being hardest. I know you guys are my aviation selection test battery guys, but you can still bring math and mechanical questions to the SIFT session, which is tomorrow. Because my training philosophy is the same, whether I'm doing SIFT test prep or STB test prep. It's the same. Mechanical comprehension and math questions. You know, you go hard on the math and word problems and things of that nature, which are most people's biggest challenge. Stay hydrated. All right. Okay, that was George's response. Oh, I got a good one. This is a good one. Dropping it on the post. And you know what? As a matter of fact, this is what I'm going to start doing. Okay, the first person to post this on Facebook or YouTube, the first person to post this question, answer this question, will get a free hour of tutoring. How about that? Oh, people are like, what? Okay. Wow. But you know what? The YouTube, you guys can't see the post when I post it on Facebook. All right. So I'm going to have to figure this out. Okay, no worries. You know what? I got it. I got this. And I'm going to do a Facebook free hour, and I'm going to do a wow. Gosh darn it. Okay. I'm going to have to type this in. That's what I'm going to do. I'm going to have to type it in for my YouTube. So whether you follow me on Facebook or you follow me on YouTube, this is a great idea. And keep in mind, this is only redeemable for my students one a month. Or maybe I'll do it. But right now, it's one a month until I figure out. I just came up with this idea, so once a month. So, okay. All right, folks, give me a second here. I'm getting it together. Minimize this and try to get this. No, we want this. All right, so So this is what I'll do. This will be, okay. I'm going to verbally say it. All right, because it's like I can't copy and paste it. Okay. So, yeah, whoever posts the answer first in Facebook or YouTube, you can't do both. But I'll be looking. The first answer I see, boom, I'm selecting a winner, so I don't want anybody to get mad at me. Like, look, okay. 2 cars started from the same point at 5 a.m., traveling in opposite directions, 40 miles per hour and 50 miles per hour, respectively. At what time are they going to be 450 miles apart? All right. I'll say it again because my YouTubers don't have, they can't really see it. So 2 cars are starting from the same point. So I'll put this on the board. So we got 2 cars starting from the same point, going in opposite directions. One's going 40 miles per hour, the other guy 50 miles per hour. At what time are they going to be 450 miles apart? They start at 8:30 a.m. I throw a curveball in there. They start at 8:30 a.m. All right. So 2 cars they start at the same point. No, well, yeah, 8:30 they start. They're traveling in opposite directions. What time are they going to be 450 miles apart? Okay. Person that drops it first is going to be the winner of the free hour. And I think I'm going to do that every week. I just came up with the idea. Now, here's the thing, Mike. You had the right answer the first time, but then you came back with 2:30 as a correction. So I'm gonna have to give it to John. I'm sorry. I know you're like, damn. Okay, so 40. Hold on. All right, 40t plus 50t equals 450. 90t equals 450. 450 divided by 90. We can chop off the zeros, and 9 times 5 is 45. So it's going to take 5 hours, right? So 5 plus 3, 13:30 or 1:30. Now, Mike, you did have it, but then you came back and you said 2:30, and that's why, it's like, your second response. So I know, and that's fair. So John, you got the free hour, brother. Congratulations. And yeah, we will. Yeah, that's about it. We made it to the end with our nice little sweepstakes question. Oh, wow. So I hope everybody learned something today. I will be here every Friday, 1700 Eastern or 5 p.m. Eastern. Again, if you are, even if you're doing OER ASTBE, you can still come to tomorrow's 2 p.m. session, which is really primarily for the United States Army aviators, but the math and mechanical, same thing. It's the same thing. All right. So everybody, please, if you haven't already, please hit the like button. And if you're not subscribed to me or following me, please subscribe and follow as well. Also, you can email me questions, even like if you got to work or something like that, and you're just like, boom, all this stuff is, it's kind of DVRable, I guess you could call it that. I look forward to seeing you guys during our respective sessions and stuff like that. But yeah, I think how many like that free hour idea? Type 1 if you like it, 2 if you don't like it. It just came to me. I was just like sitting here thinking, my people, y'all know how my brain is. I'll start thinking, oh, okay, that's a great idea. So, yeah. And yeah, at this point, it'll just be, I'll probably step it up. I just got to kind of look at it and talk to my people. 1400, 2 p.m. Eastern. Yeah, but I think that's a great idea. Well, they got all kinds of sirens and stuff going on. Okay. We actually have 1 minute left. So I saw some new faces. Harry B. I don't remember ever seeing you. You may have been here, but when I'm in the course of me solving problems and all that stuff and everything, I don't miss. But thank you for showing up. Thank you for everybody, but the newcomers I definitely want to give a shout out to in this last little session. Misha checked in. Leonardo checked in. Stacy Brown. I emailed you. Get back to me, please. Stacy Brown. Now I've seen Stacy Brown before, but yeah, Leonardo. I've seen that name as well. So yeah, guys. Tom. Okay. All right. Tom's in the building as well. All right. All right, guys. That's it, folks. I'll see you guys next week. And whether you're Army or Navy during the SIFT or the ASTB, you can come and bring your math questions because you have to immerse yourself in as much math as possible. You just have to, and that way you can kill exams that you're preparing for. I'm Kino with STEM with Kino.com. I thank you guys for showing up. I'm doing this little 2-camera thing because I'm like Facebook, YouTube, but you guys be safe. And I'll see you guys next time or during our respective appointment times. Have a great night and be safe. Goodbye, everybody, both cameras. Here's YouTube.